This is May-June 2021, paper 1-2. What is not a reasonable estimate for the physical property indicated? Okay, so first one is 2000 watts for electric kettle. Your average air conditioner installed in the house and electric kettle are generally of this power. Electric heaters are also approximately this power. Then 400 meter cube of a swimming pool. So you can take the cube root of this number just to see what you get. So when you take the cube root of 400, you get 7.4 meters approximately. So that means that if we had a pool of 7.4 by 7.4, for example, it would have this much volume. So it's also a plausible estimate, as the average height of a human being is approximately around 1.2 meters to 1.5 meters. So it's fitting to the example. Then we have 50,000 Newton seconds of momentum. Surely a lorry do weigh around approximately 2,000 to 3,000 kilograms, and if they're moving at 10 or 15 meters per second, this would be your momentum at least. But if we move to option D, we have 600 newtons of the weight of a horse. If you convert this into kilograms, this is going to be 60 kg. Now, this is not even an average mass of an adult human male. It's approximately for an average-sized teenager, right? So this is not a reasonable estimate. This is option D. Question number 2, unit Newton meter per volt. So I can see that charge appears to be in this way. How can we see that? Because the formula for voltage is equal to work done by charge. And if you make charge a subject of the formula, what do we get? We get Q equals to work done by voltage, which is F into D divided by V, which becomes Newton meters per volt. Force has unit of newtons and distance has unit of meters. So B is the plausible closest option. Question number 3 requires vector addition and manipulation. He says, what's the resultant force? So if this is the object, then there is one component because of this 6 Newton that is in the downwards direction, and one component is in this direction. So the downwards component is going to be 6 cos of 40 degrees, and the sideways component, or the x-axis vertical component, will be horizontal, will be 6 sine of 40 degrees. So the resultant along the y-axis will be 10, this minus this 6 cos of 40, and the resultant on x-axis is only 6 sine 40. Okay, now when you do so, the first letter that you're going to get will be approximately, I think it says 6 sine of 40. So this is 3.86 newtons, and this is 5.4 newtons. Now, since you want to find the resultant, it looks like that this object is experiencing towards this side a force of 3.86 and towards the upper side a force of 4.5 newtons. So you can take the resultant in the middle, somewhere along this side, by using Pythagoras theorem, right? So the resultant is going to be under root of 3.8 square plus 5.4 square. So the resultant comes out as 6.6 newtons. Although there is only one option that shows 6.6, so we don't even need to calculate the answer, but in the interest of science at least, let's see what that angle will be and how you're going to calculate this. This angle is given in respect to this, so we have this as 3.86, so it will be tan theta equals to 3.86 divided by 5.4, then tan inverse, so theta comes out as 35.5 degrees, which is 36 degrees up to 2 significant figures as mentioned in the option D. Although was not required, but for the understanding at least. Now this question is based on scaling. Are you familiar with scaling or not? How do you choose graph, or how do you choose the scale of the graph? Simple as that. He says that this graph, this scale is actually scaled from 0 to 250. Now we have that there are 10 divisions on this dial, and if you look closely, this value is actually 7.6. Okay, so this is 5, 6, 7, 8, 9. So I'm representing 7.6 on a scale of 10, so 7.6 ratio with 10, but I want to represent up to 250. or a scale of 250. So what would that be in terms of 250? It looks like this, that it starts from 0 milliamperes and goes to 250 milliamperes. Then what would be the value at this point, right? So since I'm taking the ratio, this will be an answer of 190 milliamperes. Now be careful about counting the boxes. This will be 7.6 exactly, because we can see that D is our answer, but a very close option is also given to us, which will be because of some wrong assumption, or at least wrong counting of the scale. All right, question number 5 from accuracy and precision topic. It says which instrument is which instrument is accurate and precise? We are using some instrument name X, name Y, name Z to measure volume V of the liquid. We might be using a Eureka can, we might be using measuring cylinder, we might be using other methods. So this is what the graph represents. Now, in terms of accuracy and precision, let's test for all of them, whether they are accurate and precise or not. Now, accuracy deals with the fact, do you get the correct answer, or do you get the peak at the correct answer or not? Since we're getting the peak at the correct answer, which means that my instrument has a high probability of telling me the right answer, that means that this is accurate. Similarly, if we move to precision, precision means that it should be repeatable. The experiment should be repeatable. Now, when we say repeatable, it means that no matter how many times I repeat the experiment, my value should be the same. Now, the problem is that if you look at the graph in this regard, the graph actually should have been a very sharp peak at the accurate value, or somewhere else, for example. It does not matter if it was accurate or not. It should be a sharp value. It should be a sharp graph. Why should it be sharp graph? Because it means that no matter how many times I repeat the experiment, I get the same answer, be that correct or be that incorrect. So since this is a very spread out graph in comparison to the rest of them, this is not precise. So any number of times I repeat my readings, it's a very high chance that I might get a value slightly lower than the volume, or I might get an answer slightly higher than the exact accurate answer, which is not a precise equipment. Now we move to Y. Y is not accurate. Why? Because exactly at V, I have nothing, or I have no data point at V at least. So this is not accurate very straight away. But is it precise? Yes, it is precise, because no matter how many times I repeat the reading, there is a certain answer that gets repeated so many times, or I'm getting the same answer again and again. So I can say that yes, it is repeatable. Option Z says that whether it's accurate, yes, it is accurate, because I get the maximum or the highest probability of getting the correct answer around my true answer, which is volume V. And since it is very narrow, the spread of data is very narrow, which means it is highly repeatable. Even if I repeat the experiment, I will have a high confidence that my answer will be the same or will be predictable. A large spread of data makes it unpredictable. Hence, we lose confidence in the data. Hence, the precision decreases. So there are two apparatuses which are precise, and two are accurate. So which one are those? Y and Z are precise, and X and Z are accurate. Yeah. All right. Question number 6. An object falling vertically in terms with vacuum. So of course it starts from rest, starts falling down, its speed is going to increase. Now since there is vacuum, there is no drag, and if the drag is absent, then the gradient, at least of the graph, of velocity time graph, will represent me the acceleration of free fall, which is going to be 9.8, and it should be constant, right? First point, it should increase, the speed is going to increase. So option A and B are going to be incorrect. Second point, the speed is going to increase without the presence of air resistance. So it's going to increase constantly with a constant gradient. This would have been the case if drag was present. This velocity will become constant after some time. But this answer will be, or the answer for this question will be option D, because drag is absent. The question requires a bit of mathematical manipulation. So just hold on for a bit. So first, we are supposed to find out the time of flight. You can pause the video and read the question for yourself and try on your own. I'm just going to skip to the procedure. So first we find out the time of flight, and the time of flight is the responsibility of the y-axis component, because only this is affected by gravity. And the range is the responsibility of the horizontal component, because this is the component that carries it forward, right? So if we want to find out how long is it going to stay in air, I should be looking at the y component. So the velocity y component is actually going to be v sine of theta, as this way. And the horizontal component will be v cos theta, but that's not required right now. Let's move to the question. So I will use the equation that is v equals to u plus at. I know that the final velocity is 0. The initial velocity is v sine theta plus negative of g times t. Why? Because the velocity is in the upwards direction, the gravity is in the negative direction or downward direction. When you take this v sine theta over there, this becomes a negative v sine theta equals to negative gt. Now negative cancels out from both sides. The time of flight comes out as v sine theta divided by g. One thing that's missing is that this is only the time for half of the journey. Okay, so how long is it going to take to go up? To find the time to come down again, you just multiply this time with 2. So the total time of flight will actually be 2v sine theta divided by g. Okay, so we have done the first part. The second part of this question requires to find out the range r. Okay, so the simple formula is speed is equal to distance, which is the range, divided by time t. So we take time t over there. So range becomes equal to speed multiplied by time t, which is this expression. But what is the speed that is in the forward direction? That is v cos theta. So speed is v cos theta, responsible for carrying it forward. And time has been found by 2v sine theta divided by g. So this gets simplified as 2 v multiplied by v becomes v square. This is cos theta. Then we have sine theta divided by g. All right. Okay. So this is option B. Question number 8 is from Newton's third law, and a very basic common misconception about third law with weight is exactly this question. He says that if weight of this book is the action force, where is the reaction force? The reaction force comes from the earth. You see, according to law of Newton's gravitational attraction, if object A, let's say, is attracting object B, then object B is also attracting object A, and they're both interacting with each other with the force of gravity. Over here, if I want to draw a reaction force, then it would have been the reaction of the earth, or you can visualize it in this way, that this weight is caused by earth. The earth is trying to pull the book towards itself. But on the contrary as well, the book is also pulling the earth towards itself with the same vector as the weight of the book, or with the same magnitude as the weight of the book. So the nature of the force is gravity, and two objects are actually interacting with each other. And the first is exerting force on the other one, and the other one is exerting force on the first one. So that is exactly the definition of Newton's third law. This is going to be option C. Now, this question requires a bit of an understanding. You see, he gives you 4 balls and he tells you that which one is going to hit the ground first. Okay, so first things first, let's address the issue of mass. What's the role of mass in this situation? You see, the equation for acceleration will be F equals to ma, and it would be weight equals to ma, and that will be mg equals to ma. So if there is no air resistance, for example, then either its mass, the mass cancels out on both sides, and the acceleration comes out equals to g, which is 9.8. So even if we were dealing with 4m, let's say, if we were dealing with a mass of 4m as given over here, so that would be mg equals to ma. Now to find mg, this will be 4mg equals to 4m being accelerated as a 4m cancels out. Again, the acceleration comes out as 9.8. The acceleration is irrespective of the mass of the object itself. But there is a catch. The catch is that this will be the case, or this will be observed if they were thrown in vacuum. If all of them were thrown in vacuum when there is no air resistance, then they will fall at the same time. Now the problem is that if there is no wind blowing, I can assume that there is some air resistance present in the question. And if there was no air resistance, then the question is pointless to begin with. So the air resistance is present. Now, we can't just look at the mass only. We'll have to pay attention to the diameters as well, because we know that the drag of an object depends on 2 things. First, it depends on its speed. Second, it depends on its surface area. How large is the object? So how much the wind can affect it. And obviously, if we want to understand which one is going to hit first, I will have to choose a smaller object, not a larger one, because a large object will experience higher drag or higher air resistance, although it is being pushed downwards or it is being pulled along with the same acceleration, but the problem is that it is going to encounter a higher value of drag, and very soon mg minus drag equals to ma. It will reach a terminal velocity and it will be falling slower than the rest of its counterparts. If it was no air resistance, if it was negligible air resistance, they will all fall together. But in the presence of air resistance, size would matter, surface area would matter, and of course having a higher mass with low surface area will have its own advantage in this race. So option B will be the correct answer. Question number 10 suggests it is going to be a question of momentum. No need to worry. First, let's see what he's asking us. He's asking us the value of V, which is this one. And I think both molecules are made of nitrogen. So the mass of nitrogen and the mass of molecule P and Q are exactly going to be the same. Okay. Now, what is the situation before collision? So there is only one contribution of momentum, and that is along the x-axis direction. So this particle P is bringing momentum only in the x-axis direction. But if I realize after the collision, I see that momentum P has a y-axis component. Particle Q has a y-axis component. Let's call this yq. Let's call this yp. And this is the x-axis of P, and this is the x-axis of Q. I can very well say that yp and yq are exactly equal and opposite to each other, so that they cancel each other out, because the before momentum system, the y-axis momentum was 0. There was no y-axis momentum. So I don't need to consider the y-axis for this calculation at least. I can very well simply solve this question looking at the x-axis momentum. So the x-axis momentum of P plus x-axis momentum of Q should be equal to the momentum of this particle which brought the momentum into the system before the collision. So 320 is its speed, let m be its mass. It's going to get cancelled out. So the x of P will be actually mass into velocity, which will be m multiplied by 180 multiplied by cos of 55, because we're looking at the horizontal component. Similarly over here, Q would be m into v into cos of 34 degrees. Now, how to visualize this? This 320 momentum has been converted into two parts, right? So this becomes 180m cos of 55 plus mv cos of 34 equals to 320m. Simply straightforward, m cancels out from this whole equation and you're left with just v. Now simply solve the algebra by taking this variable, this answer towards this side, subtracting it, and then dividing this with cos 24 over here. You'll get the answer of v as equal to 261 meters per second, which is option D. Question number 11 is not a part of your course anymore, but I'm going to solve it nonetheless. For other syllabuses, it's still a part of the course. So the direction of the force on the particle is in the opposite direction. This is the first hint that it cannot be a gravitational force. Why? Because gravity, the direction of gravitational field is always pointing towards the mass. And if I were to release any massive object close to Earth, it will fall in the same direction as the gravitational attraction. He says it's moving opposite. So I'll have to check the electric force condition. So electric field, let's say, I'm just assuming the situation. So this is positive and this is negative. So the electric field is from positive to negative. All right. Now I have two choices in this. I have a positive and a negative. Let's put in a negative charge and let's put in a positive charge, both. Now the direction of electric field is towards the right side. And for the negative charge, it would be attracted towards the positive plate, and the positive charge will be attracted towards the negative plate. So he says the direction is supposed to be opposite. So I guess that it's going to be a negative charge placed in an electric field. Option A will be the correct answer. Question number 12 about moment and torque. This question was very easy and straightforward. We know that torque is going to be about the product multiplied by distance between the forces, which is going to be 2r. So any one with the force, pick any one. So this is F multiplied by 2r is going to be 2Fr. Question number 13. This takes a bit of a while, but we're going to try to solve this. He says that from the side, if this is the front view, if you view this from the side, this can actually swing this way and this way. Similarly, it can come forward and it can go backward, right? So this is a sign on the outside of the screen, okay? So something like this. If it wanted to swing, it would have swung like this, right? Moving forward. And if we wanted to go back, it would have swung backwards. So this is the scenario that he's asking us. This is the front view, right? He says that if we view this from the side, okay, this is what is going to be visible to us, a very thin board. Now he says that there is going to be an angle. If I try to swing this way, or if I take this up to 90 and I release it, for example, when it comes out at this angle of 90 degrees, if I allow this to come back again, there is going to be a point where this sign gets stuck, which means that the weight of the component or the weight of the system is trying to make sure that it rotates this way, but the friction in the hinge at this point is trying to make sure that it stays in this position or is acting counterclockwise to the moment generated while it's trying to move down. So I can equate both of them. If there is a stationary stable condition where the sign does hold its position, that means that the anti-clockwise moment provided by the friction is equal to whatever the moment this hinge is going to, this weight of the cardboard is going to generate. So let's see where the weight is. So he says that the weight of the card is 40 newtons and the length is 0.8, for example, from the pivot at least. This does not matter. This is what matters because we need the distance from the pivot, and this is the hinge, the pivot of the system. The weight should appear at the very center. So I'm just exaggerating the view of this system because I'm going to write things on this and it will get messy. So I'm exaggerating the view of the hinge a bit. So my weight is going to be at the center. So if the whole hinge, for example, is 0.8 meters, the weight is going to appear at the center, which is 0.4 meters. So this is where the weight mg appears, right? And we know from geometry that this angle theta is actually going to be equal to the components I make for this, like this. This is 90 degrees. Let me make them again for you. Okay. So there is going to be one component that is going to go like this, and one component is going to go like this with an angle of 90 degrees over here and same theta angle representing over here. Which one of the two components is responsible for bringing it back to the main position? This component, which I'm going to highlight right now. This is what's going to cause it to swing backwards. This is the component of force causing it to come back to the main position, but it is being withheld back by friction of 6 Newton meters, or torque of friction by 6 Newton meters. So this is going to be mg sine theta, held back by this counterclockwise. So this is my force F, and the distance of this force F from the pivot is 0.4. So F multiplied by D is equal to 6 Newton meters at least. So my F is mg sine of theta multiplied by 0.4 equals to 6. My mg is already given as 40 newtons, so I'm not going to multiply this with 9.8 again to cause a misconception. So this is 40 sine of sine theta multiplied by 0.4 equal to 6. 0.4 gets divided, or 6 gets divided by 0.4. Then you divide this with 40 and then you take sine inverse, and the theta comes out as 22 degrees exactly. So the answer of this question was option B. Question 14 suggests that there is an elephant that has a mass this one, and by looking at the units quickly, I can see that it's going to ask me about the pressure. He says the circumference of each of the foot of the elephant, for example, if this is the leg and this is the foot of the elephant, that is 1.4 meters. Why has he given me this information? Because he wants you to find out the radius of the foot of the elephant, right? Because the formula for pressure is P equals to F over A. Now the force is going to come from the mass of the elephant. Generally, this is the trick of this. So this will be mg, so 5400 multiplied by 9.81 divided by the cross-sectional area, which is 4 into pi into the radius, which is going to be found by 1.4. So what's the formula for circumference? The formula is 2 pi r equals to the circumference, which is 1.4. So I need the radius. Radius is going to be 1.4 divided by 2 pi, right? Okay. So this is going to become 1.4 divided by 2 pi. You can exactly use the value over here as well. Why have I divided this by 4? Because the elephant has 4 legs, right? So he says on each leg of the elephant. So that's why I'm dividing this with 4, because there are going to be 4 areas. This is pi r square, right? The surface area of the foot. And if you successfully calculate this in one go in the calculator, you'll get the answer 23 pascals, which is going to be 85 kilopascals, right? A stone falls vertically in air through terminal velocity. What energy are being produced here? So He says he's talking about gravitational potential energy, and he's talking about thermal energy, which is heat. He's talking about kinetic energy. So see, first of all, dismiss the idea of kinetic energy. Why? Because if this object is at terminal velocity, it means its velocity is not changing. If the velocity is not changing, that means the value or the answer of half mv squared is going to come out the same, exactly the same, no matter how many times you put in the value of velocity, because it's a constant answer. That means that if the object is still falling down, it's still falling down, it's still falling down, it still has gravitational potential energy, but that energy is not converting into kinetic energy. If it were converting into kinetic energy, then the terminal velocity would not have occurred yet. It would still have some headroom to accelerate. It would still experience an increase in velocity, but it's not, which means that the rest of the energy, whatever it could do at best, it has already done for kinetic energy, and the rest of the gravitational potential energy is now being converted into thermal energy or heat energy or heating of the object. So that is option A. This is one of the most common questions, or one of the common questions. Question number 16 is about law of conservation of energy. He says that the plunger is moved slowly inside to a distance of 4 centimeters. And this rises by 0.5 centimeters. No problem. If this is rising up, that means whatever force you applied into the distance 4 centimeters, whatever energy you have invested in the system, you can only get it back from this side. He says that the object is actually for 12 newtons, so minimum force required to raise this would have been 12 newtons as well. So simply put, work done is equal to F into D. The force you applied is 12 newtons, or at least 12 newtons, otherwise this would have not gone up. Multiplied by 0.5, but it is centimeters, so convert this into meters by dividing with 100. So you get 0.06 joules as your answer, option A. This is also a common question. He says we want to find the ratio of gravitational potential energy gained by the car and the work done by the force F. So work done by force F will be very simple, because we know that work done is simply F into D. So this will be Fs. And to find out the gravitational potential energy, we need to use the formula mgh. So let's replace mg as it is, but let's find out the vertical height the object has gained from this point to go to this point. S is going to act as the hypotenuse, right? So this length or this height is required. So this will be simply hypotenuse, which is S, multiplied by sine of alpha. Let's replace this S sine alpha in this equation. So this becomes S dot sine alpha. And if you take the ratio according to this Fs, this is going to be in the denominator. So this is Fs. What do we get? We can simply see that S is going to get cancelled out, or the distance is going to get cancelled out. We're left with mg sine alpha divided by F, which is option D. Okay. Moving on to question number 18, definition of power. You see option B and C will be absolutely incorrect. Option A represents the formula or one of the formulas of power, but this is not the definition. This is not how power is defined. Power is defined as rate of work done, or work done divided by time, which is going to be, or the best option or a better option will be option D. Question number 19 suggests that what's the ratio of stress in the wider portion over here divided by the stress in the narrow portion. No problem. So stress in the wider portion, he says that the diameter is double. I know that area is equal to pi r square. If diameter is involved, that becomes pi d squared by 4. But since pi and 4 are a constant, I can say that area is proportional to d square. If this diameter is doubled, then the area will be 4 times. Why? Because after squaring with 2d square will become 4d square. So the area has increased 4 times. And in the narrow, the diameter is d and the area is a. Let's find out the stress in both regions. The formula for stress is force over area. The force is T in this case, so in this portion that will be T divided by A, and in this portion this will be T divided by 4A at least. Now we are dividing this wide area with the narrow area, so this becomes T by 4A divided by T by simply A. Now when you solve this, you realize that this is going to minimize to at least 1 over 4, which is going to become 0.25 as option A. Question number 20 suggests that we need to understand, or at least we need to remember the formula for extension, which is half Fx, or the energy stored by the spring. He says that the string x has f and x, no problem. So this will be simply half fx. So y is being stretched by 2f and 2x. So this goes to 1 over 2 into 2f into 2x. So 1, 2 cancels out and we're left with at least 2fx. Now, if you take the ratio between the two systems, we realize that x is at the numerator point, which is going to be 1 over 2 fx divided by y is in the denominator, so this is going to be 2fx. So this actually simplifies to fx cancels out. So 1 over 2 is 0.5 divided by 2 becomes 1 by 4. So this is option D. Question number 21, he says, must be different, laser, red light, and a green light. Okay. Now speed, they both have the same speed. We know that electromagnetic radiation have same speed. Their amplitudes can be different, no problem. They can have different intensities. They cannot have different, and intensity and amplitude are linked together. From AS, we know that intensity is proportional to amplitude square. So they're exactly, they could be different, they could be same, it does not matter. But yes, frequency, both of them will have different values of frequency, because the wavelength of red is 700 nanometers and green light is approximately around 500 nanometers. So they have different wavelengths. So dividing with V equals to F lambda will give us different answers for both of them. This must be same. Okay, so moving on to question number 22. He says, now for question number 22, I'm going to show you an animation for this to make it easy to understand. He says that one particle exists at this life stage and the other one exists at this life stage, although they are both following the same time period, right? So what's happening? One particle is at its positive peak, or let's say it's at crest, and the other one is at trough. And he says that the wavelengths, the progressive wave, two particles in the progressive wave are 10 centimeters apart. If this is that particle, or if this is this life cycle, this is what it looks like. That one particle is at crest and the other one is at trough, which means that there is actually a gap of lambda by 2 between them. So according to this idea, 10 centimeters, lambda by 2 equals to 10. So lambda is equal to 20 centimeters minimum, right? So let's try the options, what he's trying to tell us. So he says that the particle longitudinal wave, compression, nearest rarefaction. So we know that compression and rarefaction, then compression, then rarefaction. So this is CR. He says that compression and rarefaction is separated by 10 centimeters, right? So this is a plausible option, yes. B, particle longitudinal wave, compression, nearest rarefaction separated. No. You see, compression and rarefaction have a distance of lambda by 2. Compression to compression is lambda, and rarefaction to rarefaction is lambda. This is wrong. Particles in transverse wave, peak and nearest trough separated. You see, peak and the nearest trough are separated by 20. No, they're separated by 10 centimeters. So incorrect. Transverse wave, two adjacent peaks separated by 20. You see, if he says two adjacent peaks, this is what it means. Two adjacent peaks are actually wavelength, which is supposed to be 20 centimeters. So this information is also incorrect. Correct answer is option A. Let me show you what this actually looks like. So this is how those particles are actually moving. One is moving in the opposite direction, particle A, and particle B is also moving in the upward direction. They are actually 180 degrees out of phase. No matter what particle A is doing, particle B is actually moving in the opposite direction to particle A. I hope that we understand this point now. 23 was based on a CR question, which is considered to be basics of A levels at least. He says that one time base or one box is 20 milliseconds. What's the frequency of sound? No problem. Students generally try to count the whole wave, or at least try to find some similarity, some place where this is going to get easy. Let me show you around how you could have done this. You see, if I look at the graph, this is a common point where it passes from the grid exactly at that location, and this is another point where it passes from the grid exactly. So I see that from this point to this point, I can see that there are 1.5 waves. So this is one wave, and then this is 0.5 wave. So I can see that 1.5 wavelengths are being covered in how many boxes? Let's count the number of boxes along the line. So this is box number 1, this is box number 2, this is box number 3, this is box number 4, this is box number 5. So we have 5 boxes, or you can say in physics they are called divisions. So 5 divisions are being represented or are being covered in this duration, and one box represents 20 microseconds. So 20 microseconds is the total time taken to move from this point to this point. And lambda, again, can be found by this point. By dividing this with this, you are going to get 100 microseconds divided by 1.5. This is going to come out as 66.7 microseconds, right? So this is the time period for the wave, by the way, that this is how long the one wave is going to take. Now, we know that the frequency is calculated by 1 over t. So we're going to divide 1 divided by 66.7. Please don't forget to add the prefixes of micro. This is going to become 100, okay, so 14,999 hertz, which will be, of course, very easily recognized as option B. Question number 24, he says that, now this requires a bit of algebraic manipulation. I will solve this later. First, look at question number 25. This is based on memory. We already know this. He says decreasing frequency. It means you're going to start from gamma and go up to radio, right? So please be advised that gamma and radio are present in option B and A. So C and D are wrong, but how do you choose between A and B? You need to recognize that the correct format of this would be option B, because first we have gamma, then X-ray, then ultraviolet, then visible, then infra, then micro, and then radio. So we can see that ultraviolet actually comes first and then infrared comes later. Okay. Now moving on to question number 24. He says that once he hears when the object is moving towards him 1690, when the object is moving away from him, he hears 1500. So we'll have to make the algebraic equation for both situations, how this is going to go about. So when it is moving towards you, 1690 equals to f naught, the standard frequency which we don't know, into 340 divided by 340 minus x. And then when he is moving away from you, so 1500 is what is heard, f naught standard frequency, into 340 divided by 340 plus x, right? So now we understand that f naught is same for both of them, right? So let's equate them. Let's bring them into simple context. Because we want to find f naught, we realize that this is going to be equal to 1690 into 340 minus x equals to 340 f naught, and this is going to be equal to 1500 into 340 plus x equals to 340 f naught. Now, since both are equal to 340 f naught, we can assume that they are also equal. So this equation comes down to 1690, 340 minus x equals to 1500, 340 plus x. Now, when you solve for x, you will get an answer of 20 meters per second. Now, this is going to take a lot of time. What I would suggest to you is simply pick all the options, and put them into this equation and see which one gives you left-hand side equal to right-hand side. This will save you time. Otherwise, it's your choice. You want to do the algebra, it's your choice. Question number 26 suggests what could be possible cause, or what could be producing a stationary wave. You see, the open end always has an antinode and the closed end has a node. This is what we already remember. So in this loop, we can see that starting from the very basic, the fundamental frequency or the fundamental is going to look like this. So my lambda by 4 is being covered in a distance of length L. So my lambda comes out as 4L. Is this option given to me? No, this is not. So let's move on to the next possible combination. So in the next possible combination, I realize that the next wave is going to form like this, node at this end and an antinode at this end. What does this look like? This looks like this is lambda by 4, this is lambda by 2. So lambda by 4 plus lambda by 2 equals to the total length available in the column. This is going to be 3 by 4 lambda, or some students narrow it down to 0.75 lambda equals to L. So lambda comes down to 4L divided by 3. I do see a combination that it actually represents this option. Moving on to question number 7, this is based on your memory, this is based on your understanding of diffraction, what you remember from your class. He says what could be the possible position. You see, option D will be cancelled out because when it does pass through the narrow gap, it has to go like this. It has to become a curved wavefront. Option A is wrong in this regard because if we want to observe diffraction, then the gap width should be at least greater than or equals to the wavelength. This wavelength is much higher than the gap. The wave may pass through it, or you may see a small bubble through it, but it will not undergo diffraction. Okay, the gap should allow for the wavelength. Now we go to option C. Option C has a diagram error, has a problem with it. You see, the wavelength before it enters the narrow gap and the wavelength after it enters the narrow gap are different. Diffraction does not change the wavelength; it only converts them into a circular wavefront. And the most closest or the best answer is option B for this matter. Okay. All right. The wavelength is same, and approximately the wavelength looks equal to the gap width as well, at least on paper. Question number 28, he says, what is meant by coherent? This is again from memory. The waves are not precisely. They can be in phase or they can be out of phase. It does not matter. But the phase difference should be constant. It should not be a changing phase difference. Let me show you what that means. It could be a constant phase difference or a zero phase difference, which is what option A also says. But again, option A covers a very specific case. Coherent is zero phase difference or any phase difference, but being constant. Having same amplitude has nothing to do with coherence. Interference constructively where the overlap has nothing to do with coherence, right? The precise meaning of coherence is zero phase difference or constant phase difference. Let me show you what that means. So if you see this animation, you can see that the phase difference between both vectors is same. It does not matter. No matter where I pause this video, no matter where I see this video, I can see that the gap between the two peaks, the green peak and the purple peak, is going to be the same. The angle between them on the unit circle is the same. No matter if I let them run, no matter if I stop them, it does not matter. It's the same. So this is what constant phase difference looks like. It could have been zero, yes, but this is what it looks like. Continuing forward, this question requires a bit of mathematical manipulation. Question number 30, I'm going to remove question number 30 because this is from electric fields, not a part of your course anymore. Okay. Question number 29 requires a bit of discussion. So just hold on for a bit. He says that a parallel beam of light has a wavelength 420 and 630. Okay. Light is incident diffraction grating, which means I should use n lambda equals to d sine theta. He says the diffraction maximum for two wavelengths overlaps at an angle of 31 degrees, which means sine theta will be exactly the same for both of them, but we don't know what will be the order of diffraction. What could be the spacing between the diffraction grating? Again, he is asking us to guess it, but of course we're going to solve it, or we try to solve it. You see, one prediction before we start with this experiment. I know that n lambda, and if this is going to be equal to at least d sine theta, if I am using a larger wavelength, right, as 630, if I want to make sure that it appears at the same angle as the first one, then the product should have been equal. The value of n will be smaller. Let's discuss it, what it means. You see, whatever I use n lambda for at least 430 should be equal to d sine theta. And when I use it for the red color, or you can say orange color, 630, then d sine theta should also be equal to n lambda of 630, right? Now I can observe that over here lambda is higher, so this n would be a bit smaller. Okay, and similarly, if I go towards that side, this is going to be the opposite way around. This is just a way to look at this. This is not the final answer. This is just a way to look at this. So hold on for the final answer. Now let's make an equation for this. So the equation looks something like this. I know that d sine theta is exactly the same for both of them. So I can equate n lambda and n lambda of both of them equally side by side. So let's say this is n1 lambda equals to n2 lambda. So this is n1 into, let's say, 420. I'm ignoring the nanometer because I know it's going to get cancelled from both sides. So n2 into 630. Let's take the ratio of this. So n1 divided by n2, by bringing n2 over there and 430 over there, I get 630 divided by 420. What does that mean? What does that come out to? So I have n1 divided by n2 equals to 3 by 2. So n1 is supposed to be 3 and n2 is supposed to be 2. Only then this d sine theta will come out equal for both of them. Let's try this. What do we mean by that? Now I know that n1 was actually representing the 420 and n2 was representing 630, right? Let's see how it goes. Now you can try this on your own. I'm going to use n lambda equals to d sine theta, but for both of them. Okay, so first I will use 3 with the 420, but of course nanometers minus 9 equals to d, but sine of 31. Similarly, for the other option I had was 2 into 630 into 10 raised to the power minus 9 equals to d sine of 31. You can pause the video at this point, try both of the options, and you will see that your answer for D is going to come out as 2.44 into 10 raised to the power minus 6 meters, which is option C. Okay, this is what I was talking about, that if lambda is higher, you will find that the order is smaller. If the lambda is smaller, then the order will be higher, if they are supposed to meet at the same angle. This is going to be something like this, that if this was the diffraction crystal and if this was the screen, let's say that the 420 is the blue color, right? So if the blue color comes here, the blue color, this is 0. For blue color, this is N1. For blue color, this is N2. For blue color, this is N3 or order 3. For orange color, let's say the 631, this will be, let's say, order 0, right? This, let's say, maybe order 1. And exactly on here, this will be order 2. And both of them will be moving at 31 degrees. This is the visualization for that. Okay, all right. Question number 31, again from electric field. I'm ignoring this question for now. Question number 32. This is interesting in terms of electric current. You see, he says, all right, so I can see that the cross-section area is changing or is different on both edges, right? So if the cross-section area is different, I can make an equation. Now, since the graph is about terminal velocity, I have equation NA QV. Now, charge density is not changing. Charge is a constant. And of course, the current in the circuit produced by the battery is also going to be constant. So what am I left with? I'm left with the only A and V being compared. So let's keep I as a constant for now, and then it is V. And since I know that I is also a constant, let's bring V over there, or at least bring A over there. So this becomes V being inversely proportional to A. This is velocity, by the way, okay? And of course, the current was there, but I've absorbed this into proportionality because it's going to be constant. So what are we left with? We're left with an equation that shows V is inversely proportional to cross-section area. And I can see that if I move along this line, the cross-section area increases. If the cross-section area is increasing, the velocity is going to decrease, all albeit making sure that the current remains same. And we can see this from the mathematics as well, that if cross-section area is increasing, the velocity should decrease, so that after getting multiplied with everything, the answer of current remains same. So it should have been option A, right? Okay. And why a curved path? Because we know from physics and mathematics that inverse proportionalities have a graph that looks like this. Very evident in Boyle's law, which is P inversely proportional to volume. Exactly the same thing. Now 33 can be solved by two methods. It's your choice how you want to visualize this. You want to visualize this conceptually or mathematically is your choice. You see, this source can provide 2400 watts. But how much of that is actually going to reach at this point, because wires also have a resistance? This question stems from transmission of long distance wires with transformers that goes to A2 as well, or second years of A levels. Let's see how we're going to go about this. Okay, so let's find out how much current can this supply maximum provide. So the current provided by the battery on a good day, on the best day, would be this much. So 2400 equals to current, and the voltage is 240. So the current this supply can provide at very best is 10 amperes. Now when 10 amperes goes through this and comes back, it is flowing through this resistance. So there will be some power loss in the transmission line. Let's find out the power loss. So power loss can be found by I square R. And current is 10 ampere square and the resistance is 0.5. But since some power will be wasted for going and some power for going back, I'm multiplying this with 2. We get 100 watts, which means that if the supply wants to provide 2400 watts, it cannot do so. It can only do so much as 2300 watts successfully to the kettle, right? So if the kettle is receiving, let's say 2300 watts and a current of 10 amperes, then what will be the voltage? So P equals to IV. I'm receiving 2300 watts of power. Current is 10 amperes. Because it's a series circuit, current remains same. The voltage can be found as 230 volts. So I can very well quickly select the answer of 230 and 2.3 kilowatts as my option A as the answer. But let's piece it together. Let's do this piece by piece, one step at a time. What does it look like? If this had been a voltage drop, let's say, what would I use? So I will use V equals to IR. the current is 10 ampere, the resistance is 0.5, I get a voltage drop of 5 volts, which means that if the current or if the voltage was initiated at this point, it would have 240 volts. But after reaching at this point, it would have had 235 volts because 5 volts are lost in the transmission line. So what can it give to the appliance so that it still has a budget of 5 volts to go back to the supply with 0 volts so that its potential difference remains 240. So I can see that out of 240, 10 volts, 5 volts is the going budget, 5 volt is the coming back budget, will not be available to the kettle. So what is the voltage or potential difference across the kettle? 235 minus 5 will be 230 volts. And from there, we can calculate the power because 230 volts are being received at 10 amperes. So IV 10 multiplied by 230 will give me 2300 watts of power, which again gives me back to the first option. So the 2 ways to solve this, 2 ways to look at this. I've discussed both of them. Question number 34 is based on memory. He says which graph represents which component. So we have a metallic conductor at a constant temperature, and if it's a metallic conductor constant temperature, then its graph is going to be a straight line, no curves at all. So the only straight line graph is actually Y. So this is option B or C, could be anyone. Let's move on. Semiconductor diode. So semiconductor diode actually is going to be X. Why? Because diode's graph starts an abrupt increase in current after crossing the threshold voltage. After becoming forward biased, they will allow a very high flow of current. So X appears that its trend is going to increase in this way. So X is going to be the diode and Z is going to be the filament lamp, option B. So filament lamp, how it behaves is that if you keep on increasing the voltage, first it follows the Ohm's law, but gradually it starts going like this. Why? Because even if you keep on increasing the voltage, the current stops increasing because the resistance has become so high that small changes in voltage do not even register on the ammeter. So whatever voltage now you're pumping into the circuit, voltage is work done by charge, or voltage is the energy of electron. Whatever energy you are giving to the electron to go through the filament lamp is not being converted into its speed or current, it is being converted into heat and glow and light energy. Question number 35. He says that resistance is 9.5, diameter is this, resistivity is this, the length of the wire, no problem. Very straightforward. The formula will be resistance is equal to rho L over A. This is what he wants us to invoke or remember at least. So we have the values. Let's replace all the values. So we have 0.9, sorry, not 0.9, but 9.55. So 9.55 equals to rho is given to us as the resistivity, which is going to be 4.9 into 10 raised to the power minus 7. Sorry. And length is what we want to find out, divided by cross-sectional area. Since it's a wire and has a diameter, we'll use pi r square, but diameter has to be divided by 2. So 0.28 into 10 raised to the power minus 3, because it's millimeters, divided by 2 and whole square. When you successfully solve this, you will find the answer of this length to exactly come out as 1.000 something meters, which is going to be option A. Please perform the algebra correctly. This is the only way you're going to lose this. Question number 36 also was a tricky question, but let's see how it goes. He says that Z is being moved towards X. You see, if you move Z exactly at this point, this is a piece of wire, and wire has a zero resistance. If the wires have a zero resistance, their voltage will be 0. And since this R is connected in parallel to a 0 voltage, that means this R is not participating in this equation or in the system to begin with at all together. This is not even part of the system anymore. Okay, he says that read Z is moved towards X. What's going to change on the voltmeter reading? See, voltmeter is connected across the supply voltage, which is EMF E. And we know that there is an internal resistance of the cell as well. So the equation, what does that become? EMF is actually equal to not only the voltage of the resistor that is on the outside, but also equal to the voltage of the internal resistance, which is the internal lost voltage, right? So since this is actually measuring the terminal potential difference, let's bring this over here. So this is going to be E minus IR. Sorry, let's write this down with smaller internal resistance. So this is IR equals to V. This is what the voltmeter is measuring. So if we were to model this cell properly, this is what it would look like. There is an internal resistance that is R. Since there is going to be a current in the circuit, so this voltage is going to be V equals to IR, which is going to be I with small r. Now, when you move towards this side, the overall resistance of the circuit increases. The first step is the resistance increases. Why? Because if you move this banner up to this point, this resistor vanishes. And we know that whenever resistors are connected in parallel, let's say the Z had moved to this point, then this resistor would have been parallel to X. We know that in parallel, the resistance actually falls down, primarily simply because the formula becomes 1 over R plus 1 over R equals to 1 over R. When you put in the values, your overall answer comes out to be smaller. You can try this theory on any circuit of electricity. You will find these answers. So if this is connected at this point, R is eliminated in the circuit, is no longer participating in the circuit at all, as discussed earlier. So only this resistor is remaining in the circuit. Now, the resistance increases. So the second step would be that the current in the circuit decreases. According to simple V equals to IR, keep on increasing the resistance, the current falls because of the voltage, because the voltage is same. Now, if that happens, the lost volts starts decreasing. The lost volts. What are the lost volts? This is the lost volt. You see, if this answer starts getting smaller, why? Because current is decreasing. So multiplying I with R and internal resistance will give you a smaller answer. The EMF will be experiencing a smaller loss with the minus sign, with smaller reduction from the minus sign. So the voltmeter reading will start increasing because now less energy is being wasted in the internal resistance and more energy is available on the outside. So the option that fits this description is option C. The voltmeter reading increases because the current is decreasing and the lost volt current has caused its lost voltage to decrease as well, leaving behind more voltage for the rest of the circuit. 37, he says Kirchhoff's first law, which is about simply current, or technically it's about conservation of charge. So that is option A. Straight away, current dividing into these two branches, sum of current entering the branch equal to sum of leaving the branch. Some of you might notice that this option is also correct, and it is correct, but this is not the answer for first law. This is basically second law, and option D and option B are incorrect to begin with. Now, question number 38, he says that, and in this question, you are actually required to use the voltage divider rule, or at least potential divider rule, or be familiar with that. Otherwise, this will take you a very long time. He says that the R has a voltage of 1 volt, probably. No, it's the 12 ohms. 12 kilo ohms has a voltage of 1 volt. And of course, if this is a series circuit, then voltage is divided. So 5 volt must have gone with this one, because the total voltage is 6. So 1 gets this, so this gets 1, and this gets the rest of the voltage. So I'm very sure about this. Okay. All right. Now he says, what's the value of the resistance R? Now it can be solved in two methods. If you apply the voltage divider rule directly, it would look like something like this. It would be R divided by R plus 12 multiplied by the EMF of the battery 6 equals to whatever voltage, which is 5. Other way of doing this would be using the 12. So 12 divided by R plus 12 multiplied by 6 should have been given me the answer of 1 volt, which is given in the question. So I guess the second one, I can use equation 1 or equation 2 to get the value of R. And there is a third method, which is mentioned in your syllabus right now, that the ratio of voltages will be equal to the ratio of resistances. So no problem. If I want to find out R1, let's label this as R1. I know that its voltage will be 5 and the other voltage is 1 and the other resistance is 12. So this equation becomes R divided by 12 kilo ohms equals to 5 divided by 1. So when you take it over there, this becomes R equals to 60 kilo ohms. And by the way, if you solve this and this, you also get 60 kilo ohms. All right. Part 39, he says we have to guess what this is. So by simple charge conservation, I can see that this is beta positive. So this will be 1 less. This will be 11. And since beta has 0 on the upper side, this will be not affected. This is going to be 23. So 23 and 11. So option C will be a correct answer. Question number 40, again, based on memory, he says beta negative decay, a neutron changes to proton. Okay, fine, we know this. A neutron changes to a proton, which is P11 plus beta 0 minus 1 plus and a neutrino, right? Okay, so he says, what's the change in quark composition? So we know that neutron is made of up, down, down, and proton is made of 2 ups and 1 down. So generally, he summarizes that 1 down changes to up. Because up, there is no change, down to down, no change. This is the change. So the most accurate option representing this condition is option A.